Hello. So the goal of this lesson is showing you how to solve one-step equations with addition and subtraction. In class, we were working on showing the equation with a model. And so we represented green squares for positives and red for negatives. So the first thing that I want to do is I just want to review what we've done already, and that's demonstrate solving through a model. So if we look at an equation like a balance, like a scale, this side of the equation must be the same as this side. And in the game of algebra, figuring out what our variable is how you win. So the first step that we've been talking about is when we see a subtraction problem, we're going to KFC, keep flip change, so that we add the opposite. Now, let's draw a model of this equation. So on this side of my balance, I have a variable, and then I have 5 negatives. So I'm going to demonstrate that with 5 reds. On this side of the equation, I have 6 negatives. Now, in our game, we talked about legal moves. How do we get rid of these 5 negatives so that x is alone? And we talked about the way to do that is through 0 pairs. And so we're going to add the opposite. We're going to add 5 positives. Whatever we do to this side, we're going to do to this side. So we're going to add 5 positives. And then we talked about when we have a positive one and a negative one, that's a 0 pair, so it cancels out. In this case, I have 5 negatives and 5 positives. So all of these cancel out, leaving you with just an x. On this side, I cancel out all my 0 pairs, and over here, I'm left with a -1, which means that in solving my equation using a model, x equals a -1. Now remember, I can plug that back into my equation. So if x minus 5 equals a -6, and we've determined x is -1, then we can rewrite this by substituting a -1 minus 5 equals a -6. So if I add the opposite, -1 plus -5 is indeed -6. So this checks out. Now, taking our model and applying it to problems without using manipulatives or models, let's see how this is going to work. So the very first thing that I'm going to do is I'm going to create my scale on the paper. This side has to equal this side. The next thing I want to do is I want to KFC, keep flip change if I see any subtraction. So now my equation reads m and a -9 equals 15. Well, just like in our model, I want to cancel out the -9 by adding the opposite. And so I'm going to add +9 to this side. Well, remember, if I do that to the scale, if I add 9 to this side of the scale, it's going to be uneven. So I have to balance it by adding 9 to this side. Then I solve. Here's a 0 pair, -9 and a +9. Cancel that out, so I'm just left with m. So I'm going to bring that m down with my equal sign. Now I just have to solve 15 plus 9, which is going to be 24. So I believe that m equals 24. My last step is to prove that I'm right by checking. So where I have m, I'm going to plug in 24 minus 9 should equal 15. And indeed, when I take 24 minus 9, I get 15. So 15 equals 15. This checks out. Let's take a look at another example. All right, so again, I have my equation, and I'm going to create my scale. This side needs to equal this side. Notice that this time the x is on the right side of the equal sign. And that's okay. You don't have have to worry about that. So I'm just going to focus over here on this side. Because I want x by itself, I'm going to add the opposite. Well, the opposite of a positive 34 is going to be a negative 34. So over here, I'm going to add a negative 34, because whatever I do to one side, I need to do to the other. Then I'm going to cancel out any zero pair. So 34 and negative 34 cancel out. I'm left with x equals, and then I have a negative 25 and a negative 34. Well, I remember my rules of integers. I'm adding the same sign. So I keep and add. So 5 plus 4 is 9. 2 plus 3 is 5. Negative and a negative equals a negative. So if I take a look at my original problem and plug it in, I have negative 25 equals a negative 59 plus 34. And because I have different signs over here, 59 minus 34, this is further from 0, it's negative, so I end up with a negative 25. Negative 25 equals negative 25, so I know I must have solved this correctly. Now, you are also going to be dealing with rational numbers. So in some of your equations, you are going to see decimals and you're going to see fractions. The same rules apply. I'm going to start by creating my balance. This side needs to equal this side. Then I'm going to use KFC to rewrite. And then to get x by itself, I'm going to add the opposite. The opposite of a negative 3 2/10 is a positive 3 2/10. So I add there, and I add there. Because remember, whatever I do to one side, I have to do it to the other. This cancels out. So I'm left with x equals. Now I have to do some solving here. I have a negative 1 8/10 and a positive 3 2/10. Because I have different signs, I'm going to find the difference. So first thing I remember about dealing with decimals is I need to line them up. So I'm going to find the difference between 3 2/10 and 1 8/10. And I am going to rename, because 3.2 is further from 0 than a negative 1.8. This is positive, so my answer is positive 1 4/10. So I believe that x equals 1 4/10. If I go back and plug it in to check, 1.4 minus 3.2, I should get a negative 1.8. So if I check that, add the opposite, 3.2 minus 1.4 indeed gives me a negative 1.8. What's awesome about checking with algebra is that you'll know you're right before I will. You plug it in and check, you'll know that you've done the problem correctly. This example has rational numbers in the forms of fractions. Don't be scared, you've done these before, so let's just take a look and apply our rules. The first thing I'm going to do is I'm going to create my scale. This time I have a variable p and 5/6. On this side, I have a negative 1/2. Taking this a step at a time, I have no subtraction, so now I'm going to add the opposite. The opposite of 5/6 is a negative 5/6. I'm going to add a negative 5/6. Over here, I'm going to add a negative 5/6. Because these also are zero pair, this cancels out and I'm left with p equals. Now, because I have fractions, I have to remind myself that when I'm adding fractions, I need to make sure I have common denominators. So, right now I have the denominators 2 and 6. Remember, with fractions, I like to look at the larger looking denominator, which is 6, and see if this denominator can evenly go into it. It can, so I'm going to use the denominator 6. This stays the same because I haven't changed the denominator. But because I went from 2 to 6, I have to multiply by 3. So, negative 1 times 3 is negative 3. Now, I can go ahead and add these together. So, a negative 3 plus a negative 5 is negative 8. And bring along my 6. So I have 8 over 6. Now because I have an improper fraction, I'm going to have to rename that. So 8 divided by 6, I'm going to get 1 6 out of there with 2 left, 1 and 2 6. So P is going to equal a negative 1 and 2 6, which I can simplify to negative 1 and 1/3. So I believe that P equals a negative 1 and 1/3. Now, the only way to know for sure is to check this. So I'm going to go ahead and I'm going to put in a negative 1 and 1/3 for P plus 5 6 should give me a negative 1/2. So I'm going to go ahead and add this to check. So when I add 1 and 1/3, in this case I know that it's 1 and 2 6, I know that because it's negative, I'm going to find the difference. So I'm going to rename here because I can't take 2 from 5. So this is going to give me my 8 6, and 8 minus 5 is 3. Bring along my 6. And if I simplify that, a negative 3 6 is the same as a negative 1/2. Because negative 1/2 equals 1/2, I know my problem checks out. Let's take a look at one last example. This time I have rational numbers that include a mixed number. And again, the x is on the other side of the balance. I'm going to use my same strategies. I'm going to create my balance. I have no subtraction, so I add the opposite. Plus a negative 1/3. Plus a negative 1/3. This cancels out, so I have x equals. Now again, I'm dealing with fractions and mixed numbers, so I'm going to start by rewriting my denominators. I have a 4 and a 3. 4, 3 doesn't go into 4, so I think, well, 4 times 2 is 8. No, 4 times 3 is 12, so my least common denominator is 12. To get from 4 to 12, we multiplied by 3, so this is going to be 3 and 9/12 rewritten. To get from 3 to 12, I multiply by 4, so this is going to be 4/12. Now I go ahead and check, am I adding or subtracting? In this case, I have a positive and I have a negative. So I need to find the difference because I have different signs. 9 minus 4 is 5, and along my same denominator, and then I'm going to bring down my 3. I know that it's positive because 3 3/4 is greater or further away from 0 than 1/3. Now again, the only way to be sure is to plug in and check. So right now, I think x equals 3 and 5/12. Let's see if I'm right. So my problem read 3 and 3/4 equals, I'm going to plug in for x, 3 and 5/12 and 1/3. Okay, so I'm going to quickly solve this by rewriting. So I have the same denominator, 5/12. Add that together, 5 plus 4 is 9/12. Bring down my 3, and when I simplify 9/12, I get 3 and 3/4. Since 3 and 3/4 equals 3 and 3/4, I know that I have solved this correctly. Make sure that you have your notes and these examples in your notes so that you can refer to them when you do your practice.